All right, the next lesson, if you are somebody who pulls the notes from Teams and you go into where it says copies of class notes and you're pulling the notes, what I'm actually going to do with the next lesson is I am going to break it down into 3. So if you're looking at it, it says topics, it says domain and range, changing forms, and then writing specific equations. So instead of trying to cram that into 2 lessons where we might have a weird break point in it, we're going to break this up into a whole lesson on just domain and range, a whole lesson on just changing forms, and then a whole lesson on writing specific equations. That means that by the time we're done with that last lesson, you will be ready for your next test. So that's just kind of a heads up, is you've got 3 more lessons, and then we'll be looking at the next test. If you've fallen behind on the 4 lessons that we've had so far, now would be a good time to kind of do some catch-up work, because these lessons are going to be fairly short. So before we talk about domain and range, specifically for quadratics, let's go back and talk about what those definitions actually are. Great. So these are definitions that I think you've seen before. I kind of think that they introduced the concepts of domain and range a little bit too early. I was not asked questions about domain and range at all until I got to Algebra 2, and even then I did not like them. It took me a long time to get comfortable with them. And what I think might happen is that they're introducing this vocabulary and they're introducing these words early in Algebra 1, and then what happens is you end up with this kind of incomplete or like patchy idea of what they are, but never developing any comfort with it or a concrete idea of like, I understand what this concept is. So that's why I think it's worth it for us to kind of take a day and explore some things about domain and range to try to develop just a better idea of what they are. So when you're first introduced to the idea of domain, you might be told like domain is the X's. And while that is broadly true, it's also incredibly vague, and it doesn't translate well into anything more abstract. So this is like the kind of problems that you've probably done, and we've done in this class as well. 3, 4. Okay. And so you're given a group of points. Okay. And you're asked, what is the domain? And you would say, okay, well, the domain is 1, 2, and 3, because you would be looking at just the X's. And that's technically true. Like that would be the correct answer if you were asked, what is the domain of this function here? The problem with that is what happens when your function is now an equation. And so instead of a group of points, now you have something like y equals x squared. Well, now how do you answer that question? So I want to introduce broaden the idea from all possible x values. Notice that I am using the word possible, not just what x values do I see, but what x values are possible. And I'm going to kind of broaden this out and give you a slightly different definition. It's not different, it's just broadening it. I want you to think of the domain as all the numbers that we could plug in for x. So if you think of like just whatever it was that I had up here, like 2, 2, okay? You could think of that as all the numbers that have been plugged in for x. This is just a very restrictive function. It's a function that's 3 points. And how many times do we see functions that are just 3 points? Not very often. So I want you to kind of think about that, digest it for a second. It's all the numbers that you could plug in for x. So if you were looking at something like this, and I were to ask you to build a table out from it, what numbers could you plug in for x? Here's the deal. Usually, in most cases that we're going to deal with, the answer to that question is all real numbers. So if you wanted to plug in 0. You could plug in 0, and 0 squared would give you 0 out. If you were to plug in, you could plug in a 1. You could plug in positive numbers. Actually, let me do this out. Okay, I'm actually going to expand on this. I'm changing my plans right at the minute, right on the spur of the moment. So you could plug in a 0. You could plug in positive numbers. So you could do like 1 squared is 1. You could plug in negative numbers. -1 times -1 would give you positive 1. But you could also plug in decimals. There's nothing stopping you from plugging in a decimal. And you could do like 0.5 times 0.5, and you would get like, what, 0.25. You could plug in a fraction. Let's do a negative fraction. You could plug in -1/3. And so -1, I'll do this one out for you guys. -1/3 times -1/3 would give you positive 1/9. Okay, just gonna do that one out. You multiply your fractions straight across. Little mini fraction review thrown in there. And so if you think about it, there's nothing that's stopping you from picking any number you want for the x. And so in this case, we would say the domain is all real numbers. Now, way earlier in the year, we talked about real numbers, and I defined a real number as any number that you could locate on the number line. There are numbers that are not real. We have not studied them yet. And so if you can think of a number, if it's anywhere at all on that number line, okay, fractions, decimals, positives, negatives, including 0, okay, 0 is real, then you could plug it in. And so for all parabolas, the domain would be all real numbers, and it's because there's no what we call restriction. You could plug in anything that you could get for an x. Now, when we go to express that, there are several different ways that you could write it. So domain for all quadratics, but here is what I want you to make sure that you do. You're going to write a capital letter D followed by a colon. Okay, I will take off if you do not use the correct notation. Just like in a Spanish class or something, if you forget an accent mark or a tilde, it might not be a big deduction, but like an N and an Nye, forgive me, I haven't really studied Spanish with like in a classroom, are two different letters. They're considered two different letters in the alphabet. And so like these things matter, like the right notation. So you're going to have a D followed by a colon that indicates the domain. You can write it like this. You can say it is all real numbers, meaning that there is nothing that is excluded from what you're allowed to plug in. You may also write this, and we've looked at this symbol before. It's kind of a wonky, funny looking R. Okay, and yeah, so you can write it that way. That means all real numbers. The other way that you can write it is using something called interval notation. Now, Photomath and many other online resources will give you your answers in what are called what's called interval notation. I do not typically teach interval notation to my Algebra 2 classes. I believe Ms. McDonald does in the honors classes, because once you get past Algebra 2, interval notation is the most common way that you will write your answers. I'm going to give you the interval notation for all real numbers, but I'm not going to give you the interval notation for anything else. If you are using interval notation on your tests or on your homework, I am going to take off points unless you explain to me that you understand what that notation is, which you are more than welcome to do. So I want to be really clear about that, because I am aware that most of your online places where you would go to get the answers are going to give you these answers in this notation. So if you do the research and you understand what the symbols mean, and you understand what they, you can explain to me why you have a bracket or why you have a parenthesis or why you have the comma and the numbers that you have, then I will give you 100% full credit for it. But because I'm not presenting it that way, that is not how I want you to present it as your answers. And I will take off points unless you offer me that explanation for it. Because tons of people are going to try to just copy it off the internet. So I'm not trying to be nasty or mean about it. I just know that that's how internet resources do it. The interval notation for all real numbers, though, this is the one I will give you. It means it goes from negative infinity to positive infinity, and then that is enclosed in parentheses, and the parentheses are absolutely 100% important. So that's another way I can sometimes catch students that don't really know what they're copying, is they'll copy it like that without the parentheses, and that is wrong. That the parentheses absolutely have to be there. And so that gives a tip off to me that I have a student copying stuff from somewhere that they don't really understand what they're copying or what it means, and they're they're not really doing the work. So the parentheses have to be there. And what that means is you can pick anything from negative infinity to positive infinity. Now, this is true for all quadratics. So if I were to look at, like, say, this quadratic, okay, I could plug in anything that I want for the x. You think of positive numbers, negative numbers, decimals, fractions, and so forth. Now, the range is a little bit different. So let's go back and look at our definition for range. If domain is all of the possible x values, then range, it should be a colon right there. There we go. Is all the possible y values. But again, if you're doing this, well, like you have the 0.12 and the 0.22 or whatever, you just go through and you look at the y values and you list them, and that's fine. But what happens when you have an equation? Like, now, how do you describe what the y's are? So we're going to do the same thing with the y's as we did with the x's. We're going to kind of broaden the definition out so that we can apply it to more functions. It is all the numbers that we could get out for y. And if you think back, like with our definitions of domain and range, like it's one of the definitions that is often tossed out there is your x values are your inputs. It's what you put into the equation, and the y value is the output. So when you're asked for the input, that's why we phrase it. It's all the numbers that we could plug in for x. And then for y, it's all the numbers that we could get out for y. So let's go back to this example for a moment and think about all the numbers that you could plug in for x. Okay, remember this is x squared. This is where the tables, I know tables are like boring and tedious and they take us forever to build, but they also are useful. They help us see patterns. They help us explore how the numbers work. So looking at this, if I plug in a 0, I get 0. If I plug in a 1, I get 1. Now notice when I plug in a negative 1, I still get a positive 1 out because negative 1 times negative 1 gives you a positive 1. When I plug in a decimal, I get a smaller decimal, but it's still positive. If I plug in a negative fraction, when I multiply it by itself, I get positive. There is a restriction on the y values. So I'm going to pause the video for a moment in class and let you think about what numbers couldn't you get for y. Here's the question again. What numbers can you not get out for y? All right, so I don't actually know how that went in class because I'm recording this video ahead of time, but hopefully at some point somebody stumbled, tripped across, or you guys worked together to come up with this idea. You will never get a negative over here in the y column. You will never get a negative. And so you can get 0. So we don't want to say it's always positive. Okay, we don't want to say it's always positive because 0 is not positive. But no negatives can come out. So if we were talking about the range here, all the numbers that we could get out for y, we need to find a way to write that the numbers will never be negative. So let's come over here to, we'll do a new slide here. Now, this one, I am saying the range specifically for y equals x squared because the range is going to be different. So for domain, it's domain for all quadratics. So basically, any question on your next test where I ask you for the domain, I've given you the answer. unless you don't study, in which case you won't remember the answer because you won't remember it by the time we get to the test. Now for the range though, the range is different for all quadratics. Remember for this one, y can't be negative. Y cannot be negative. So the way I'm going to write that, I'm going to use an capital R, not the funny looking R, okay, not the R for all real numbers, okay, not that one there. And then a colon. And the way I'm going to write this is y is greater than or equal to 0. Y is greater than or equal to 0. That means I can get 0 out and any number greater than 0 out. But I'll never get a negative. And that's how you would write the range. Now, there's another way to write that using interval notation, but we are not going to go there today. Now, let's see if we can tie this into what the graph looks like. So on the graph, the parent function for quadratics looks like this, with the vertex at 0, 0. And let's kind of compare this. If I were to like trace this graph, remember in the last lesson, I was really adamant that these are not vertical. Like they get very, very steep, but they're never vertical. And what that means is I move along the x-axis and I keep going in that positive direction. And we're going to call this like this is positive infinity out here, okay? We start at 0 and we're going out to positive infinity. This parabola keeps going. It's eventually going to get over here, okay? It might be like up at the moon by the time it gets there because it's got to go up and it gets so steep, but eventually it is going to make it over here. Same in this direction. This is like my negative infinity down here, okay? It will eventually make it over there. Like I'm exaggerating, you know, what this looks like, but eventually the parabola is going to get over there. But if you look at the y-axis for this, the parabola comes down, it gets all the way down to y equals 0, and then it turns around and it heads in the other direction. The y value is never negative. It never goes below the y equals 0. And that's why your domain is all real numbers, or you could say like negative infinity to positive infinity. That's kind of where the interval notation comes from. And the range, we say y is greater than or equal to 0, because when you're looking at the y-axis and the up and down, it stops at the 0 and it doesn't go any lower than that. What you need to develop in order to answer these questions is a sense of looking at the x-axis, the left and right, as separate from looking at the y-axis. So you're going to look at like how is the function behaving, moving along the x-axis. Well, it keeps going to the right, it keeps going to the left, versus how is it behaving on the y-axis. All right, I'm going to do another example. We'll do actually a couple more examples for this, and then I'll try to summarize it up. So this one says state the domain and range for, and let's notice that this is a quadratic, and I know it's a quadratic because I see the x being squared. Now this is a quadratic. Now what I'm going to do here is embed some review of some stuff that we've already covered. This is a quadratic in vertex form, which means that we are able to see the flip, the left, the right, the up, the down. So the way I'm going to answer this, first of all, I'm going to answer domain because I have already told you what the answer for domain is. Every quadratic, the domain is all real numbers. Every quadratic. Okay, so we don't need to, like, there is going to come a time where we're going to look at some functions where the domain is not all real numbers, but you can plug in anything you want for that x. Like, we are okay. In fact, like, the only things that you really need to worry about are, like, when you have a denominator, because you're not allowed to divide by 0, so that might eliminate some options. And square roots, you can't take a square root of a negative, at least not yet. So that will hinder your domain. So I say this over and over and over again, like the domain for a quadratic is all real numbers, and then you'll have some questions on the test which will be state the domain of this quadratic, and there will be people who will leave it blank, people who will write IDK, and I just can't think of any reason for that other than I did not study, because the answer to that question is all real numbers. Now the range is going to be a little bit trickier. So for the range, we're going to go back and draw on some things that we know. We know that this is flipped over, and I know that because of the negative. I know that it goes left 3, and I know that because of the plus 3 on the inside. And I know that it goes up 2 because of the plus 2 out here. So what I'm going to do is I'm going to use my skills to do a quick sketch. And I know it goes left 3 and up 2. So I'm going to put a dot right there, and I know it's flipped over. Now, the reason I am leveraging the graph, remember I think I've said like most of the time we sketch graphs. We're not looking at a perfect thing. We're sketching it because seeing it will help us answer some other questions about this relationship. It keeps going to the left and it keeps going to the right because those are not vertical. That's where we get the domain is all real numbers. But notice on the y-axis, so let's like focus on that up and down. I have values down here, so y can definitely be negative, y can be 0. Okay, that would be my x-intercept right there. But I do have a highest y value. If I look very closely at that, the highest value that y can be is a 2. So how can I express this using the notation that I have? So I'm going to put my r over here with my colon. Y can be up to 2 and anything below 2. Or less than 2. So I'm going to write y is less than 2, but it could also be equal to 2. So let's make sure we write it that way. So y is less than, and I can tell that because it's pointing down because of the flip, y is less than or equal to 2. And that is not interval notation. If you're going to give it to me in interval notation, I am going to ask you to explain it. So y is less than or equal to 2. All right, one more. So this is, say the domain and range for y equals x squared minus 6x plus 4. So please write down the domain as all real numbers. It's all real numbers all the time if you're looking at a quadratic, which we are because of the x squared. Now for my range. I have y, r with the colon, and then y. Now, this is going to be a little bit different. What I need to figure out is where is the vertex. I'd like to be able to do like a quick sketch of this, and I'd like to be able to find out where the vertex is. So thankfully, we just covered a set of lessons earlier this week about how to find the vertex, because we've done how to graph these. So there's this formula, the opposite of b over 2a. Well, in this case, let's make sure we have this. We have a is 1, b is negative 6, and c is 4. The opposite of negative 6 is positive 6 over 2 times 1. So 6 divided by 2 is 3. Okay, wonderful. That just tells me where the axis of symmetry is. It doesn't tell me where the actual vertex is. To get the actual vertex, I need to go and plug that 3 in. And so 3 squared is 9 minus 18 plus 4. So we have negative 9 plus 4, which is negative 5. Okay, so what does that tell us? Let's see. What am I going to do here? All right, so let me copy the 3, negative 5. And the equation was y equals x squared minus 6x plus 4. Now, this is not flipped because there's no negative out front. So if I were to do a quick sketch of this, I would do 1, 2, 3, 1, 2, 3, 4, 5. Here's my vertex, and it's not flipped. Now, this is a quick sketch. This is not, like, this is actually like a terrible, you know, it serves the purpose, because the purpose that I want is to be able to look at it. If you have a graphing calculator, you can avoid this altogether because you can dump the equation into your graphing calculator and you can take a look at it. But notice my y values, okay? The y values, we're looking at this up and down, because the x's, we know it keeps going this way and it keeps going this way. The y values bottom out right here at the negative 5. Okay? And y can be negative 5 or anything above negative 5. Or, if I change how I say that, it can be -5 or greater than -5. And so y is greater than or equal to, and there's your domain, and there's your range. So this lesson is already plenty long. I think we covered enough of that, and we will come back and talk about this some more, and I don't know what I'm going to give you for homework at this point, but we're going to call it quits on this lesson for today.